Hey, it's Ben Greenfield. Get ready to strap your propeller hat on because we are going to go for a deep scientific ride. This podcast is brought to you by what I consider to be one of the most versatile tools in my supplements cupboard, meaning I can take it at night before I go to sleep to enhance my neurotransmitter formation. I can take it before a fasted workout to increase my blood levels of some of the things that are super necessary for anabolism, but that I don't get from some of the other common pre-workout foods one might eat. And furthermore, it's something I can consume and maintain all the benefits of being in a fasted state while still being able to charge very hard through a workout without risking loss of muscle and without risking central nervous system fatigue. I have been using this stuff since 2013 Ironman, so almost 6 years. This has been a pretty potent weapon in my performance, my sleep, and my recovery toolbox. It is called aminos. More specifically, it is called Kion aminos, Kion aminos. It is a blend of essential amino acids, not branched chain amino acids, which spike your blood sugar, those little bastards. This is essential amino acids, 99% utilized by your body compared with about 48% for egg protein, even less, 32% for meat and poultry and fish, whey protein and soy protein, 18%. Only 1% of branched chain amino acids actually get utilized by your body. This stuff, 99% gets utilized. You can grab it in a wonderful, cool lime powdered flavor. Or in a tablet. I tend to just travel with a tablet and eat them like Cookie Monster. I go through about 10 to 20 grams of these per day. They're also really good for staving off your appetite, too, when you're in a fasted state. It's all over at Kion. They're called Kion Aminos. Get Kion. Just go to getkion.com to grab those. Another thing that you may want to add to your toolbox, should you be a fan of occasionally delving into pasta and bread and not wanting to go decommission a bathroom or experience the somewhat embarrassing bloating and gas and even more concerning gut inflammation and gut irritation that occurs from gluten. Now, I don't think gluten's the devil. I'm not one of those guys. I don't think that gluten is going to end our planet or cause World War III, but I do love to eat my wife's delicious slow fermented sourdough bread that she makes. I like to take my kids to a local restaurant where we order these popovers that are indeed made from wheat. Tonight, I'll take my family out to dinner, and honestly, I'll probably have whatever bread they bring out to the table, and I will pop 6 of these before I actually eat. It's called Gluten Guardian. It's a supplement. It has this enzyme in it called dipeptidyl peptidase. And this is a form of a protease that breaks down the exterior coating of gluten protein, and it makes it so that you are able to consume gluten with none of the side effects. So you can get it, and you can get 10% off of the already discounted price if you just go to Gluten Guardian, just like it sounds, glutenguardian.com/Greenfield. I think that anything that helps you better handle gluten is a pretty dang good idea. And you can get this stuff at glutenguardian.com/Greenfield.
In this episode of the Ben Greenfield Fitness Show,
we hired a lot of nurses that were on that study, and they saw real recovery firsthand. So we're trying to get to a place where, we can get more definitive, certainty around cause and effect associated with all this stuff, so we can all save time. It's just as valuable to figure out what's not working.
He's an expert in human performance and nutrition. Voted America's top personal trainer and one of the globe's most influential people in health and fitness. His show provides you with everything you need to optimize physical and mental performance. He is Ben Greenfield.
power, speed, mobility, balance. Whatever it is for you, that's the natural movement. Get out there. When you look at all the studies done, studies that have shown the greatest efficacy.
All the information you need in one place, right here, right now, on the Ben Greenfield Fitness Podcast.
Hey, This is a little bit uncommon that I would record the intro for you right now after that big commercial break that I realize you may or may not have fast forwarded through. Don't fast forward through the commercials, by the way. I procure amazing discounts for you. I don't know if you're aware that a lot of the discounts I'm able to get for this podcast, I actually tell people, hey, you can't advertise on my show unless you give my listeners discounts they're not going to get other places. And so when you fast forward the commercials, you miss out on all that goodness. But anyways, that's not why I am recording for you right now before I welcome my fantastic guest to the show. Reason is, we delve pretty deeply into the science on this show, and I want to kind of give you a summary of what we talk about so that you are armed and that your brain is prepped, and should something go over your head, you're just kind of ready for it. So the first guy that you hear talk on today's show for quite some time, his name's Mark Ehrman. I'll introduce him in the show, but he has this thing called the Young Blood Institute. There is enormous potential for young blood, or what is called heterochronic plasma exchange, to actually reverse biological age. This is essentially the equivalent of putting the blood of young mice into old mice, except they're doing this with humans. And even more amazingly, as you're going to find during this episode, they're actually reversing Alzheimer's with plasma replacement. So that's one of the things that you're going to learn about. It's called heterochronic plasma exchange. Mark geeks out quite a bit, but the long story short is that if you go to the Young Blood Institute's website, you can see more about what they do. I'll put all the links to everything we talk about over at bengreenfieldfitness.com/plasma. My other guest, Tom Ingoglia, because this is a three-way on this show, Tom talks next about aging markers and a whole bunch of different ways to track and test aging that go far above and beyond what I've talked about before. Like, you've probably heard me talk about telomere testing before and blood testing, but he talks about a whole bunch of other tests and even mentions this aging clocks booth that, frankly, at the time of this podcast might be a little late for you, but they have this thing in San Diego called Revolution Against Aging and Death, RAD Fest. It's a conference, a whole bunch of scientists and doctors there, primarily in the anti-aging and what they call the radical longevity sector. They are going to be doing a lot of these aging tests that Tom talks about there, but you can also just go to Tom's nicotinamide adenine dinucleotide, it's a mouthful, NAD clinic website, and he'll have more information about that stuff there too. Speaking of NAD, we talk about whether nicotinamide riboside, which is the darling of the anti-aging sector right now, is indeed the only way to boost NAD. Turns out, spoiler alert, it's not. These injections and IVs actually do cause NAD to be able to cross the cell membrane. Then we talk about this thing called the Bredesen protocol, which breaks down Alzheimer's into 6 different types of Alzheimer's: inflammatory, what's called glycotoxic, atrophic, toxic, vascular, and traumatic, and how this protocol by Dale Bredesen and the book by the author of the same name kind of lays out a multimodal approach to be able to heal Alzheimer's. And we talk about some other little biohacks and tools that can be used for Alzheimer's. You'll hear Tom, he does a pretty good job name dropping things that I try to correct him on, because I know these are names that he mentions that you might not be familiar with. Like, he talks about a person named Nady Brady. He says Nady Brady a few times. That's just a person who wrote a book on NAD and neurodegeneration. We talk about exosomes as well, and I will link to all the different studies that Tom mentions as we go into those specific categories. But when it comes to exosomes, one of the big things he talks about is that exosomes that you can get injected into your body, they contain something that I haven't talked about on the show before called GDF-11 mRNA. And GDF-11 is this very interesting substance. Not only do you get it when you do these parabiosis experiments, meaning when you replace some of your plasma with young plasma or with replacement plasma, but GDF-11 repairs DNA in stem cells. It is something that people are injecting now and claiming that their hearing and their smell and their sight are all coming back. It's the same in all vertebrates, so you can get it from animals. Very interesting molecule. So we talk about that one a little bit, and I'll put a bunch of studies on that in the show notes too over at bengreenfieldfitness.com/plasma. And then we talk about ways that you can naturally increase your GDF-11 levels. 2 particular supplements that we talk about, very common, easy to find: quercetin, and also what are called tocotrienols. tocotrienols, about 150 milligrams of tocotrienols per day, or about 500 to 800 milligrams of quercetin per day. Might even be more effective than some of these more expensive anti-aging supplements that you find floating around there. So these show notes are quite robust. I have links to everything from exosomes to GDF-11 to this book, The End of Alzheimer's, other Alzheimer's references, some DNA anti-aging clock websites that they have to be able to determine your brain aging and your body aging. The Young Blood Institute website, everything is over at bengreenfieldfitness.com/plasma. Again, this is a little bit more scientific than even some of my previous episodes, but I think you're really going to dig this one. So let's go ahead and join up with Tom and Mark. You've no doubt heard of this by now, that in an attempt to live a longer time, there are some crazy anti-aging enthusiasts out there who are getting themselves injected with the blood of young humans via a process that goes by a whole bunch of different names. But there's one form of this called plasmapheresis. And my first guest on today's show is named Mark Erdahl. He's a technology entrepreneur from the Silicon Valley. He's got a bunch of patents. He's worked in big data, and he began his career at IBM's medical instruments subsidiary that pioneered this process of plasmapheresis. He went on to found something called the Young Blood Institute, which actually does this plasma exchange therapy to rejuvenate the body's stem cells and restore the immune system and prevent the onset of a whole bunch of age-related diseases. So we're going to talk about that just a bit with Mark today, but it gets even better because I have another guest on today's show, and he's been on the show before. I had a podcast a couple of years ago called The Next Big Anti-Aging Drug, Everything You Need to Know About NAD. And in that podcast, believe it or not, we talked a whole bunch about this stuff called nicotinamide adenine dinucleotide, or NAD. And as you learned in that episode, my guest Tom got very sick when he was in Costa Rica, and he was prescribed a bunch of antibiotics. He suffered some pretty adverse reactions. It was told he'd have problems, especially like gut issues, things like that for the rest of his life. He developed a whole bunch of food allergies, insomnia, anxiety, muscle pain, chronic fatigue syndrome. We went into his whole backstory in that podcast episode that I'll link to in the show notes for this episode, which you can access over at bengreenfieldfitness.com/plasma. That's bengreenfieldfitness.com/plasma. Anyways, though, through Tom's 8-year battle, he got prescribed a whole bunch of different pharmaceuticals, and he eventually turned to this stuff called NAD. Wound up, long story short, completely curing him and getting him off all these medications he was on. And I've hung out with Tom, and he's just like this. I would describe him as a ripped beast now. So he's definitely come a long ways. And we raced a Spartan race together down in Las Vegas, and he's definitely come a long ways since using these NAD therapies. And he's actually a guy who I talk to who's way on the cutting edge of anti-aging and longevity. And that's why this podcast is about a lot more than just young blood and NAD. We're going to talk about biohacking Alzheimer's, and we're going to be talking about reversing biological aging, different biomarkers you can track and test, how to measure biological age, the biggest obstacles to age reversal, how you can get more involved in the anti-aging community, a whole lot more. And again, I'll link to everything, all the studies we talk about, all the previous podcast episodes, everything. If you just go to bengreenfieldfitness.com/plasma, PLASMA. All right, so let's go ahead and jump in. First of all, gentlemen, welcome to the show.
Thanks, Ben.
Great to be here, Ben.
And that second voice that you heard, that was Tom. So, Tom, you had the idea to have both Mark and you on at the same time. So tell me what it is that we're going to be talking about on today's show.
Well, I think we're going to be talking about, Mark can do a very good job talking about young blood or heterochronic plasma exchange. We also want to talk about the different ways you can measure biological age, and that's becoming more important as new types of therapies develop, and just a sort of explosion of information out there about about all these different therapies that may reverse age, and so we need to find metrics that could monitor where we're at. And then we also want to talk about Alzheimer's. Alzheimer's seems to come up because it's the number one risk factor for that is age. So and then I do want to to sort of dust the conversation with all these other different ways that we can potentially reverse the age, and I think we're going to have a little debate about NAD. That's unavoidable. So,
well, we got a lot to talk about, but I have to admit the thing that intrigues me the most right now from everything that you've just listed off is this idea of replacing your blood with plasma, and I would love to hear from you, Mark, exactly what this whole Young Blood Institute thing is. And I do know, and I'd love for you to mention this as well. There's another company in San Francisco, I think they're called Ambrosia, that's doing some kind of a blood exchange. And I'm curious what the Young Blood Institute is and how it's different than this other company, Ambrosia, that's doing, from what I understand, young blood exchanges, and how this whole plasma exchange treatment protocol works. So can you jump into how we can all inject young blood into ourselves and walk around looking like we're 13 years old?
Well, I don't know if we're going to get to 13, but we could try. The Young Blood Institute, first of all, is a 501c3 nonprofit. Okay, so we've got a kind of a humanitarian research mission to conduct clinical trials in what we call heterochronic, big word for different ages, heterochronic plasma exchange. Basically removing the old plasma and replacing it with young plasma or purified plasma components. So yeah, obviously a lot of people have been discussing the concept for a long time. There's other people out there that are trying this in different forms. The Ambrosia folks, as far as I know, and I could be wrong, I understood from one of their MDs in Florida that I met that what they're really doing are infusions. Okay. They're not necessarily getting rid of the old stuff.
Infusions mean that they're taking like blood from healthy young donors and infusing that into other people.
Yeah, well, yeah, plasma.
Okay. And just for people listening in, when you say plasma, is that the same thing as blood?
No, plasma is the kind of the straw colored liquid that's it's 95% water, but it's 50% of your kind of blood volume is plasma, roughly, and that's what's carrying all of your red cells, white cells, platelets, immunoglobulins, proteins, et cetera, throughout the bloodstream, as well as all the cytokines and signaling molecules and so forth. So there are the primary components of blood are plasma, red cells, white cells, and platelets. There's a lot of detail below all that, but those are the primary components.
And from what I understand, correct me if I'm wrong, plasma is like about half of our blood volume. It contains like the proteins and the fibrinogens, the antibodies, and basically all the good stuff that you would find in blood.
Bingo. That's
okay.
it.
All right.
When I actually, you mentioned this I think in the beginning, but I actually started my career of all things with IBM Biomedical Systems, who had invented what we called back then the blood cell processor. Way before my time, back in the 60s, there was an IBM engineer named George Judson, who had a son with leukemia.
Judson, like the Jetsons?
Well, not Judson.
Okay.
Jud, yeah, but easy to remember. And he had a son with leukemia that needed regular, white blood cell exchange, or leukapheresis, as we call it. And at the time, they had a manual process to separate blood. All the blood components by specific gravity. It's kind of like oil and vinegar, oil and water, et cetera. And you can put blood on a shelf and it'll stratify. But basically, he invented this machine to draw the blood out of one arm, spin it around in a centrifuge, while it's spinning around, it's inside of a special little plastic disposable that would allow him to essentially extract, as things kind of layered up, any particular component he wanted. Could be white cells, red cells, platelets, plasma. So the first application for the blood cell processor was leukapheresis, motivated by the fact that his son had leukemia and he's trying to figure out how to kind of automate the process and donate blood once a week instead of whole blood or donate a component of blood once a week as opposed to whole blood every 2 months. And so he got a leave of absence from IBM. They got a grant from the National Cancer Institute. And, sometime around, I think, 65, 66, they basically created this machine. And then IBM, who's got kind of a history of, what we call entrepreneurial ventures, created a business unit out of it. A lot of people don't know, but IBM actually helped with a Harvard professor create the first heart-lung machine back in the 40s. And they've done interesting little side projects, but they basically decided to create a business unit out of this concept, basically. And that's the business I joined when I got out of school at UC Santa Barbara, and kind of by accident. But I'd gone down for an interview with the computer guys, and I got there, and they told me there was a hiring freeze and there were no jobs, but there might be this opportunity over in this little business unit called Biomedical Systems. And so I joined it and kind of got my crash course in medicine. They hand me Tabor's Medical Encyclopedia, and I'm calling on. I'm literally at the head of open heart surgery because they used our products in open heart surgery. Like my second month on the job, watching the whole thing. And but then within a year of me joining, they sold the business unit and they redeployed us into the computer group, which was where I had intended to go in the first place. And it really wasn't until a few years back when I started reading about the mice research, exchanging young and old blood, and I thought, man, this would be really easy to do in humans. Why are they, spending so much time with mice? And
what were they doing with mice? I mean, you talk about the mouse research. Some people might not even be familiar with this mouse research. What exactly was going on with that?
Well, there's a fancy term they call heterochronic parabiosis, which in a nutshell means
parabiosis. Yeah, that was the other word I was looking for. That's basically the word I see thrown around more than this plasmapheresis, parabiosis.
Yeah. Look, let me tell you what they're doing. They're slitting open the sides of two mice. They're stitching them together, and they're measuring the effects of the complete exchange. They call it the systemic milieu, basically meaning it could be blood, it could be guts, it could be, all sorts of stuff that's just kind of floating around. But essentially, it's like they're creating Siamese twins out of mice that were, it's like it's the opposite of a separating Siamese twins. It's like creating Siamese twins in mice, and then measuring. They basically, stitch together an old mice and a young mouse, and measure what happens.
So they're not actually taking the blood out of the old mouse and transferring that in the young mouse. They're actually connecting the two mice together.
Well, the first range of experiments, sort of starting in 2005, were just stitching the mice together. Now, in the last couple of years, they've developed some devices that essentially allow them to deplete blood out of one mice or the other, and then independently kind of inject it. It's a very difficult problem in mice because they're very small, and their veins are incredibly tiny, and so it's not a very sophisticated process. Let me say that compared to humans.
Okay.
I mean, we've been doing this in humans for 50 years. I mean, there are
really.
Literally, oh yeah. Well, since the 60s. Yeah. I mean, there are millions of procedures of all sorts of what we call apheresis every year, primarily for autoimmune diseases, which is the big indication, if you will. Probably half of the treatments in the world today are plasmapheresis, and and the majority of those are used for autoimmune disorders, things like multiple sclerosis, myasthenia gravis. There's a whole list of, kind of a dozen more rare diseases where they've found what we call therapeutic plasma exchange. It has a beneficial effect in removing pro-inflammatory factors, ridding the body of autoantibodies, antibodies that attack themselves, regulating T-cell disorders, things like that. So, and that's where we made the connection. I realized, very quickly that, I went to visit, I've met a lot of the mice research people, let me say that. And they're all good people, but most of them don't have a lot of experience with human medicine. So when I set up the Young Blood Institute, I did so with an eye to, recruiting, some of the best immunologists, endocrinologists, nurse practitioners, MDs, et cetera, that have got, real experience in real medicine and in particular with plasma exchange. So, like most of our nurses have been doing this for like 30, 40 years. Typically. And so we've got, institutionally a lot of experience with that. And because I realized that, what we've really got to do is explore these new indications that are, plausible, because what we've done is sort of connect the dots between autoimmune disorders or autoimmunity and immunosenescence, which is essentially the immune system. Well, it turns out that autoimmune disorders and immunosenescence have three fundamental things in common: the presence of autoantibodies, the presence of T-cell disorders, and the presence of pro-inflammatory conditions. So the interesting possibility is the use of essentially an old technology to a new indication, which is aging associated disorders that are caused systemically by immunosenescence.
Okay, so basically when you're putting the plasma from a healthy young donor into somebody who comes in there to the Young Blood Institute, primarily what you're going after is a stronger immune system?
Yeah, that was our original and remains kind of the base core hypothesis, is that, we could reboot the immune system, just kind of like rebooting your computer, right? That the majority of subjects are going to be on a path of immune system decline. We die of immunosenescence, right? The immune system craters, and the minute it craters, we become vulnerable to all sorts of different age-associated disorders.
Okay. So what exactly happens when somebody comes in there?
Well, first of all, what we do is we partner with guys like Tom, right? So Tom has a clinic in San Diego.
Yeah, the NAD injection clinic.
Right. And so we have a network of really doctors and clinics across the country. And we partner with those clinics to host the trial and sort of provide the oversight, the facilities, the local MD, et cetera. We run the what's called an internal review board, IRB study protocol. We provide the nurses, the protocol, the equipment, because it's very specialized. And then we deploy into each location, and we kind of share the responsibility. They're qualifying the subjects, overseeing, the procedure generally, and then we're providing the actual. We come in and kind of turnkey provide the plasmapheresis service for the subjects in that location, in each location.
Are there any kind of risks to this? Like if I was going to go down and do something like this because I want to track my telomeres and see what happens to those, or if I want to get a stronger immune system, is this the type of thing that just anybody can wander in and do?
Millions of procedures are done a year. Okay. And we have started with what is arguably the safest protocol, possible, where we use purified plasma components, because, plasma is 95% water. So there's a whole multi-billion-dollar industry that basically collects plasma donations. Usually they have plasma collection centers around universities and places like that. They then distill out the water. They take the key ingredients, which are primarily the albumin, the immunoglobulins, and the fibrinogen, and they pasteurize it, which means heat it up, wash it, purify it, and it goes through decades-old FDA-regulated process. And it's kind of like frozen lemonade. I mean, they ship around the country. Add water, got plasma. So it's a very safe protocol. There's about a 4% risk of a transfusion reaction, and the transfusion reaction risk is relatively minor. It's not really that much different than if you went and donated blood at a blood bank. Potential for flushing or fainting or things like that, which usually after someone goes through the process, you just make sure they sit down for a little while and have some water, maybe a snack or something like that. But it's not it's considered to be a very, very safe procedure. It's probably one of the safer procedures in the medical world today.
When somebody comes in and does it, do they get multiple plasma exchanges, or you just do one plasma exchange and that's it, you're done?
Well, in our protocol, or at least our first protocol, you go through 6 exchanges, and which is different than, let's say, an infusion protocol. And the reason being that we're using specialized equipment to remove the old plasma. And but the fact is if you're drawing blood out of one arm, you're spinning it around, you're extracting the old plasma, you're putting the other blood components back in the other arm, and then you're adding the new plasma.
Wow.
After a while, pretty soon you're drawing the old plus the new. It's kind of like trying to change the oil in your car while it's running and you didn't drain the oil pan. And so you can only get 2/3 of the old stuff out, roughly, plus or minus 5%. But before, that's kind of a max. And so you've got to wait, let it settle, come back within, a week or so, and then do it again. And there's a curve. It's on our website, but there's sort of some mathematical statistical history from, the 12th edition of hematology that basically demonstrates mathematically that it really takes 6 treatments to get rid of, let's say, 98% of the old stuff.
Is that 6 days in a row? You're coming in 6 consecutive days, or do you split those up?
6 weeks in a row.
Oh, 6 weeks in a row. Okay.
Yeah.
Gotcha.
Yeah.
Gotcha.
Yeah.
So do people need to travel to Silicon Valley and the Young Blood Institute to do this, or like you mentioned, you're partnering up with clinics so people could go do this at a clinic in their town?
Yeah, that's why we're doing it, because if you live in San Diego, okay, go to Tom. If you live in Raleigh, North Carolina, well, we've got a doctor there. If you live in Florida, we've got docs there. I mean, we've got doctors in Texas. And because of our model, it's relatively easy for us to add a new location. So if we have somebody who lives in Spokane, Washington, and they want to undergo the treatment, kind of the first question is, well, who's your MD? And would they be interested in hosting the procedure and becoming what we call a sub-principal investigator, because they're actually a part of the study, right? We don't just rent space from these guys. We integrate them because they have a lot of wisdom, and they're kind of like a human biomarker, right? That we de-identify all the data from a study standpoint, but a doctor can make, and a nurse, frankly, can make observations that get recorded into the record for the treatment. So maybe they notice that somebody after 3 treatments is hop, skipping, and jumping, or dancing. Well, there's a relevant fact that we wouldn't capture in a blood test.
Okay, so when people are looking for a place to go do this, can they just go to the Young Blood Institute website and do a search for practitioners, or where to do this in their local community?
We don't really the list of practitioners on the website, but they can submit an inquiry, and we can work with them. I mean, the bottom line is we're flexible. If we have a doctor in the area, great. And if we don't, and they've got a doctor, well, that works too.
Okay. All right. Gotcha. So when people are doing this, what exactly are you measuring? I mean, what is it that you're looking at to see if this plasma exchange is actually working? Like, are you tracking biomarkers or tracking specific data points?
Yeah, I think that's probably the most significant thing we're doing, actually, to be honest, because we've probably got more technology testing capability than Stanford, Johns Hopkins, and Harvard combined. I mean, we have sort of gone to the mat with respect to rolling out the most advanced, sophisticated scientific test technology on the planet.
Like what?
Well, the key technologies that we're using is called time-of-flight mass cytometry, which provides an extremely comprehensive understanding of cell phenotypes, signaling pathways. It really enables what's considered to be system cell biology at a single cell resolution. It's called single cell proteomics, the large-scale study of proteins, basically. And it's a very advanced method to measure and phenotype cells that can generate significant detailed understanding about the cells in relatively small samples. And it's sort of a successor to what's called flow cytometry over the last 30 years, where we've been measuring immune systems and immunology and so forth. So we've got literally 72 biomarkers just in that alone. Then we've got some ELISA technology, enzyme-linked immunoabsorption assay. It's been around for a long time. And we do a few tests using kind of the old ELISA technologies because we can't get it on the new ELISA. But then there's a new technology called digital ELISA.
ELISA?
ELISA, E-L-I-S-A.
Okay.
Stands for enzyme-linked immunoabsorption assay. And it's the digital ELISA is anywhere from 100 to 3,500 times more sensitive than the traditional ELISA. And that enables detection and quantification of biomarkers that previously were almost impossible to measure, and it gives us also automated results, so we can minimize operator variation and give us very sensitive, accurate detection of cytokines, proteins, all sorts of assays. We've got about 24 biomarkers there. Then we've got a mass spectrometry assay for Alzheimer's that's novel and unique. One of our investigators is basically the inventor of this assay, and it was clinically proven in Japan back in like 2012, 2013 to be an accurate measurement, or roughly the equivalent of a PET scan in detecting what's called amyloid beta plaque in the brain, but detecting which is considered to be at least the evidence, if not the cause, of Alzheimer's, using only a blood sample. So the problem with Alzheimer's is that typically by the time you get diagnosed, it's too late. You get diagnosed because people are observing problems. You may not remember those problems. You get in to get the diagnosis, and the disease has already taken its grip. And so that's the big challenge because it's not necessarily obvious until it's too late. So what we're trying to develop is, and essentially with all of these things, actually, not just the Alzheimer's, but essentially a series of early detection biomarkers that would allow us or enable us to prevent the onset of a number of diseases before they actually begin to occur or begin to become significant. So along the lines of, colon cancer and breast cancer, early detection regimens that have been very successful, we're also trying to essentially develop a kind of a next generation of early detection techniques revolving around, the immune system, neuroimmunology, neurological disorders, et cetera. And then, of course, we also have incorporated DNA methylation markers and genetic markers and other kind of newer, more nascent types of quote unquote biological aging The difference is we're not using those as kind of the key measurement. We're actually working with the methylation companies to look at all of the detailed sub-data underneath so that we can correlate it with the other data that we're collecting. And so one of the unique things we're doing is getting a significant variety of different types of biomarkers and biomarker testing technologies that we can then correlate to get kind of the whole elephant, if you will, right? Like any one test or any one approach, you might be looking at the trunk of the elephant, you might be looking at the tail, you might be looking at the leg. We're trying to get the whole picture. And so in order to do that, we're getting as many tests as we possibly can, including a new one we added relatively recently. I mean, just after we got started, but we didn't discover it until then. But we've got a new one on blood viscosity, which turns out to be kind of interesting. It turns out that, as blood ages, it thickens. So there's been a lot of historical measurement of this in, let's say, research settings, but it really hasn't been translated or applied to the broad populace. And yet it kind of makes sense that if your blood has turned to sludge, it's kind of hard for your heart to push it around. So, and what we've noticed in some of our treatment therapies is that when you're getting rid of the old stuff, some of which may look a little thicker than, in a young person, that after a few treatments, it starts to thin out or normalize. And we've had people report, wow, I had the best sleep I've ever had in my life, and
after getting a plasma exchange.
After getting, one or two plasma exchanges. And if you look at the output plasma in those cases, and this is, different people have different kind of experiences, let me say that. And we haven't, because we cryo-freeze the blood and we measure it all at a future point in time, all at the same time. We don't have all of our data in yet, but just experientially, what we're kind of seeing and observing is that there are different types of blood that, or let's say characteristics of plasma that are coming out of people. And those attributes are normalizing after, several exchanges.
Hey, I want to interrupt today's show to tell you about umeboshi paste. Umeboshi paste. I actually just got back from Japan, and this stuff is called pickled plum puree, umeboshi paste. It is made from, you guessed it, pickled pureed umeboshi plums, and it replaces butter and salt to allow you to make the best corn on the cob on the face of the planet. If you're a corn on the cob guy, you got to get this stuff to put on corn on the cob. But it also works very, very similar to miso, which is something that I cooked with quite a bit when I was in Japan recently. It is a traditional Japanese product, but it's very difficult to find organic umeboshi paste. And I don't even know if I'm pronouncing that 100% correct. If you're Japanese, you're trying to jump through the podcast and strangle me, my apologies. For example, the ingredients in this particular umeboshi is just umeboshi plums, sea salt, and what are called beefsteak leaves, or shiso, another popular Japanese ingredient. Well, the finest organic stuff that is certified kosher, gluten-free, raw, vegan, and sourced directly from farmers is just one of the many products that you cannot get on Amazon, but that you can find at Thrive Market, which is a revolutionary online marketplace that makes healthy living easy and affordable, because it lets you shop for thousands of these non-GMO foods and natural products, but always at 25 to 50% below traditional retail prices. They have a whole bunch of stuff, like I mentioned, that you can't find on Amazon, and they have these prices that you cannot beat even at your local organic foods store. They're also giving all of my listeners an extra $60 in free groceries and free shipping. Their price is already up to 50% off, but they're giving all this to you. And you just go to thrivemarket.com/Greenfield. That's thrivemarket.com/Greenfield. That gives you everything that you need from Thrive Market, including the free shipping, the 30-day trial, $60 of free groceries, and you need to try this umeboshi paste. I'm just saying. This podcast is also brought to you by Gainswave. Gainswave is the revolutionary new bedroom biohack for guys who want optimized sexual performance. You don't need to take Viagra. You don't need to take any other little blue or other multicolored pill, gas station dick pill, you name it. Save your money, save your liver on all these pharmaceuticals, and instead use these pulsating sound waves from Gainswave. What you do is you go in, I do this once every month to once every 2 months. You go in, they use pulsating sound waves to increase blood flow to your crotch. It gives you a firmer, more resilient erection, makes your orgasms last way longer. It causes the growth of new blood vessels to the penis, so you see an increase in size, increase in oxygen delivery, increase in nutrients. Yep. Did you know your penis needs nutrients? Bet you didn't. Well, it does, and Gainswave delivers them. So I've swallowed the Gainswave Kool-Aid. That is a horrible analogy, isn't it? I should not say that. I've started drinking the Gainswave Kool-Aid. I have better erections, better sex, better orgasms, the works. So what the folks at Gainswave are doing is they have a really good promotion available to my listeners. You get 6 treatments. They're going to throw in a free treatment on the house. You get 12 treatments. They'll throw in the 13th on the house. Easy to do. You just go to gainswave.com/Ben. That's gainswave.com/Ben to find a provider near you. Enjoy. Gainswave.com/Ben.
Now, what do you think, based on all the different anti-aging biomarkers that you just listed off, people should be tracking? Like, what would be the lowest hanging fruit for people? Because, I mean, even if somebody can't get into the Young Blood Institute, because you're tracking a lot of different things there, what would you say would be the lowest hanging fruit for people to actually track if they just wanted to kind of do this on their own or talk to their doctor about running certain tests or, doing like a telomere length analysis through something like teloyears or something along those lines? What would be the best anti-aging biomarkers, in your opinion, to track?
Well, that's a pretty tough question because, to be honest with you, we're probably less concerned about quote unquote age as a human construct of the Roman calendar than, our cells don't know about age, right? Our cells don't know that they're 24 or 48 or, 94. So what we're really focused more on is the function of the body. And I will say, just on the telomere point, that, we are cryofreezing the blood, and we hope to be able to test it at a future point on telomeres. But the problem with current telomere testing is that they typically access telomere lengths on the total, what we call peripheral blood mononuclear cell populations, PBMCs, derived from whole blood. And basically, PBMCs have a mixture of cell subpopulations that have dramatically different telomere lengths. So, like naive cells versus effector T cells, for example, or T cells versus NK cells. And T cells tend to have the longest telomere lengths. So you could come in the morning, we could do a blood draw, and you might have 30% total T cells, and things look pretty good. And later that day we do a blood draw, and we only get 5% T cells, and you might have aged 10 years. So the whole methodology around telomere testing is sort of fraught with complication. And we're looking at methods of possibly spinning down the cell population subsets so that we could look at the differences in those specific cell population subsets. For example, naive CD4 cells, CD8 T cells, et cetera, that we can compare apples to apples. And even so, we're still not sure. The National Institute of Aging has done a lot of study on this. It's not clear there's an absolute correlation to quote unquote age. But it is of interest in terms of its correlative value to us. So, and we're not really kind of in the biohacking community, we work with people who are biohackers, obviously, in the sense of dialogue, collaboration, discourse, et cetera. But we're kind of trying to get to the bottom line. What's working, what's not? And the answer is we don't know. There's a lot out there, and just understanding which tests matter is a whole, important part of the equation.
Mm-hmm.
But
you're going to get whatever tests you do, there's always going to be someone that's going to poo-poo it, because there's so many different theories of aging, and there's a few scientists that like to poo-poo the telomere length, and so it's just really the approach is to find multiple ways to measure aging, aging markers, and biological aging clocks.
What's a biological aging clock?
So a biological aging clock, if you want to study aging and you're using various therapies, you might have to wait 50 years to see what the results are, or you could do your study in 75, 85-year-olds, and then have something that's a certain statistical power in order to you won't have to wait as long, or you have something like telomere length that spits out a particular age, and that would be another means to determine whether or not the therapy is any good. So the telomere length is one, and then Zymo put out this DNA methylation aging test. They have a few now.
What's Zymo?
So Zymo's a laboratory, and they've worked with a scientist, Stephen Horvath, who he's sort of a biostatistician that they looked at he's looked at DNA, and he's seen a pattern statistically from methyl groups that are attached to certain parts of the genome. So at various points in your life, certain molecules attach and detach to the genome, and based upon that, it spits out a very high correlation age. And so out of this high correlation, there's even sort of they're starting to think that perhaps some of aging is coming from the way in which the methyl groups attach to the DNA.
Okay.
So.
All right, gotcha. So as far as this biological aging clock and how to reverse it or how to slow it down, are there any other things that you've found, Tom, as far as ways you can track biological aging or slow the rate of this biological aging clock?
I don't have the access to some of the machines that Mark does, unless we partner together, and we've been talking quite a bit since we met at this cocktail party in Florida, where he presented this, and we said yes, let's definitely work together, because we're so passionate about aging and just the commonalities with Alzheimer's. What we've done in our nonprofit and at NAD Treatment Center is we've looked at some of the more popular inflammatory markers, and we've also looked at heart age, which is measuring arterial stiffness, brain age, which is we use CNS vital signs to compute a brain age, and then lung age we're using spirometry, so how much air you could breathe out, and then we use photometry to detect the age of the skin elasticity. So those are some of the things that we'll be doing, and then also we're going to be using there's a new instrument out on the market called Age Meter that we'll have at RAD Fest, which is a conference that's going to be held in San Diego, September 20th. So we're going to have one of the largest booths, if not the largest booth at RAD Fest, and doing IVs of NAD and exosomes, and also we want to.
When is this RAD Fest? September 20th.
September 20th. I hope
that's soon.
That is soon. I hope you can get the podcast out.
Yeah, I think this podcast comes out like the week that you'd be doing this RAD Fest. So tell me more about RAD Fest and tell me more about this anti-aging booth.
So Mark is going to be there, and so he'll be able to talk more about plasmapheresis, and also we will be doing what we want to do is we want to really encourage people to get their aging clocks done, and we're using a system called PhysioAge that calculates the aging clocks, and it'll spit out an age. And at the end of the day, it's the more data you can get, the better. There's always not going to be enough data to calculate age and aging markers. But I'd really love to have maybe, if legally possible, have sort of a contest where people can sign up and calculate their age, and then maybe at the next RAD Fest we could figure out who's made the most progress or whatnot. So RAD Fest is something that I'm very excited about. I think that it's an amazing conference. It's very different than some of the other conferences.
What does RAD Fest stand for?
So RAD Fest is the Revolution Against Aging and Death. It's the biggest conference on radical longevity, and it's a place where you can go and hear about studies that people are doing, trials, make investments, have dinners with scientists and doctors, it's a social gathering, and it's a nonprofit, so it's pretty inexpensive. It's just a few $100 to go and get a ticket there, and I think Mark and I we'll have a side room to talk about maybe doing some other case studies. I know Mark and I are very interested in looking at other ways besides this very promising plasmapheresis. So, for example, I had lunch with a scientist 2 months ago, Greg Fahey. We were talking about. He wanted to talk to me about an NAD test that he was working on. And he said this is a huge game changer. So he wanted to, maybe have some sort of partnership and figure out how we could help each other. But little do I know, I find out later that he's developing a therapy for thymus regeneration. And because if you lose your immunosenescence, then you could be healthy like Jack LaLanne and then catch pneumonia, and a few days later you're dead. So that's one of the things he's working on, and he's one of the foremost authorities on cryonics or cryonic vitrification, which is taking cells or organs and cryonically preserving them. So it's just like, so I had no idea who I'm talking to, and then but these are people that I've met at RAD Fest the last couple of years, and it's just it's a great environment to see people that are very passionate about longevity. Like
yeah,
Mark
you
and
guys are obviously you're talking about things that I have not heard anybody before talk about when it comes to aging and longevity. But one thing, just to clarify here, what are the different parameters you're measuring at this booth? Just list them off again, because it was very interesting. You talk about lung, skin. What are some of the other parameters here?
Heart age or arterial stiffness, and then I think that's called the sphygma core, and then brain aging. We're going to use the gold standard CNS vital signs, and then you've done those air tests, spirometry, where you blow as much air out of your lungs as you possibly can, and then there's a skin test that uses a laser to measure the skin elasticity of your forearm and produces a skin age. And so so looking at all these different parts of the body, you're able to get a better handle on what it is your age is, and then of course DNA methylation and telomere age are they're even better when when everything's measured together. And we got a couple other ideas for aging clocks as well. And I'm going to be speaking there, so I'll speak a little bit more about the aging clocks that we're doing and encouraging people to get involved and to see if we can make changes in life expectancy, because our life expectancy's dropped 3 years. It'll be 3 years in a row. So, and our health span is declining as well. So this is something that I get really excited about.
Interesting. You guys are going to be measuring a lot of things. So RAD Fest, I'll link to that in the show notes over at bengreenfieldfitness.com/plasma. Kind of last minute, but if folks want to get over to that and check it out, it's in San Diego, right?
It's in San Diego, yeah.
Okay, all right, gotcha. So one of the things that I talked with you the last time that I had you on the show about, Tom, was this concept of NAD. We haven't talked a lot about NAD, but one kind of elephant in the room that I want to make sure I address while I have you on the show is this idea that was mentioned by Dr. Charles Brenner the last time I had him on the show, and we were talking about nicotinamide riboside, or NR. And he has this supplement called True Niagen or Chromadex. Thorne has one. Elysium Basis is another one. And a lot of these folks are saying that compared to NAD, that NR is far more absorbable and a much better way to boost your NAD levels. And we know that the NAD to NADH ratios are really important as a way to control aging and to enhance mitochondrial health and overall health in general. And I personally, I take NR, but I do these NAD injections. I've been down to your clinic and I've done an NAD IV. I do right now on a weekly basis. I do an NAD push IV, self-administered, and it's one of those things that's controversial though, because a lot of people, including Dr. Brenner, will say that NAD can't enter the cell membrane like NR supposedly can. What are your thoughts on that?
Well, how do you feel when you inject NAD versus taking NR?
Well, I feel absolutely amazing, but I'm wondering if part of it is because the injection process sucks so much and you get so nauseous and your gut feels like it's on fire. I wonder partially whether or not some of it's due to just the extreme relief that the actual injection is over. So I feel like $1 million. But subjectively, all joking aside, I feel amazing when I do my NAD injections, and I can't say I feel the same immediate noticeable effect when I take NR. But again, there's a lot of confounding variables, right? I got a needle in my arm, I'm getting this stuff injected. You kind of have that rush of adrenaline just from the injection itself. So, I'm more interested in data than my own subjective feelings.
Yeah, I'm too afraid to do the fast injection. I'm not sure if I want to
it's uncomfortable.
Encourage people to do it. Yeah, that's like being run over by a steamroller or something like that.
Yeah, I have to do box breathing the whole time. It takes me about 15 to 20 minutes to push it all in, and I take out a trash can so I can puke if I need to from the nausea, and but then it's over, and I save myself 6 hours and a flight to San Diego, baby.
Okay. All right. Fair enough. Well, many NAD scientists usually say that NAD does not cross the plasma membrane. So that the sort of consensus is sort of there. And I personally disagree with that. There was a you just sent me an article, but I haven't had a chance to read it. But there was also a journal, Bredesen. There was an Italian group in 2001 that showed that NAD can cross the plasma membrane at the 3T3 fibroblasts, which are mouse embryonic fibroblasts. So they used something called proteoliposomes, and they figured out that NAD crosses the plasma membrane via the hematosome protein called connexin 43. So if you disagree with that, then one could always go on to Sigma Aldra's website and buy 3T3 fibroblasts for $400, and they'll be shipped to your door, and you can run the experiment. But I really like the research that was done at the NAD conference that I held last January, where where Ross Grant, who you interviewed, talked about the uptake of NAD. I'm not sure, if or when that'll ever get published, but Nady Brady showed an increase in PARP activity and SIRT1 microRNA expression. And so, I thought that, and some of that research is sort of trickling out. And what I'd love to do is, I was just talking with an NMN, nicotinic mononucleotide scientist, and he's also an MRI expert. He's been doing he was trying to sell I think he was selling some technology to the government to detect lies with his MRI, but he wants to use the MRI much like a Hubble telescope goes out and peers out into the stars. He wants to use this MRI to peer into the brain before and after NAD treatment and actually count the molecules of NAD in the brain, which would be so the hypothesis is that not only is NAD in the brain, but it's also crossing the cell membrane. So he asked me to sponsor that, and he wants to look at that for NMN and NAD, and I said, sure, let's give it a go. So, so there's a bit more information, and we'll just show that in the show notes. But it's kind of neat to see the controversy and the debate. But I really do feel like to really debate to extreme, I think is really unhealthy. I think that the FDA thinks that that we should decide which is the safest and best vitamin B3 therapy, whether it's NMN or NR or niacin or what have you, and they're misinterpreting a law called the Drug Quality and Security Act, which goes far beyond NAD. There's 453 ingredients that the FDA's Pharmacy Compounding Advisory Committee is that they've reviewed, and that they've refused to review 390 ingredients, and PCAC has further rejected 71% of the 49 ingredients that they've reviewed to date. So despite a long history of safe use and patient needs, so what you have is a number of things that you love, Ben, okay, and that a lot of our listeners love, are being threatened to be taken off of the market, and it's pretty sad.
What do you mean? Why is it being threatened to be taken off the market?
They compounds like glutathione, for example. It's that for example, the glutathione push that's being threatened right now. It's going to be there's a review. There's sort of it's almost like a court hearing, and people are going to argue for and against glutathione, and they usually give about 2 or 3 weeks.
You mean glutathione IVs or injections, or just like glutathione in general?
Glutathione in general. So that means glutathione.
They would want to take it off the market?
For compounding pharmacies.
Huh.
Yeah. This means veterinarians, ophthalmologists, dermatologists,
Not that many
doctors.
people. I mean, the general public, though, that not that many folks are using glutathione in that form, right? The compounded form.
Well, I mean, if you go to a functional doctor, I mean, that's a pretty common IV. I mean, it doesn't end there. I mean, there's alpha lipoic
I guess
acid.
I was thinking most people are just ordering off Amazon, like liposomal glutathione or whatever.
But the uptake is not that, it's not necessarily that good.
Yeah.
And some people have digestive problems, and there's other things too, like thiamine, curcumin, selenium, resveratrol, magnesium glycinate, vitamin A, zinc picolinate. All those vitamins I just mentioned are vitamins that we use that we want to be using in our in an Alzheimer's study that we're doing. It's where we're combining Bredesen protocol with IV NAD. We'll be doing a lot of that stuff orally, but I mean, those are vitamins that, who knows? I mean, there's a lot of Parkinson's patients that rely on glutathione. There's vegans that want methyl B12, and there's a real risk that could go away.
I don't understand why would it go away? Why would they want to do that?
Well, I have my own reasons, but the reasons that they state is that that safety is a concern. But the reality is that you can't. There's no money involved in proving the safety of these vitamins that don't really have any intellectual property. And if there was, then essentially as soon as that occurred, then the price of these vitamins would go up, and so healthcare costs go up. But basically, you not only do you have it's sort of threatening to naturopaths and functional medicine doctors, but it's also threatening to the cost of healthcare itself. So this is sort of what's going on. So I don't necessarily want to. I don't think that a debate about NAD and is necessarily a healthy one. I just had there was a girl the other day that called up the center, and she said I'm hallucinating, and I said why? And she said, well, I took Levaquin and I have massive anxiety and I'm hallucinating. I'm like, well, hang up and dial 911 and go to the ER. She's like, I just came from the ER. They just kicked me out. And I just was Googling around and I found you and what should I do? And I was like, well, I'm not a doctor. And but there's based on some information I got from Dr. Todd Lapine, he's prescribing 600 milligrams of NAC, which converts the glutathione, and magnesium, 400 milligrams or a gram. He's able to, stave off some of the problems of adverse reactions to fluoroquinolone antibiotics. And so, lo and behold, she goes out and she takes that. So I tell her to go see a doctor, of course, but we were communicating, and she said, now the hallucinations aren't as bad as they were. They've really calmed down my anxiety, my insomnia. And so, doctors need to, there really should be some freedoms that doctors and compounding pharmacies and patients have when they're really desperate and they don't have anywhere to turn to. The silver, for example, the silver IVs is an alternative to these antibiotics, and that's being threatened to come off the market. The myrrh, from the three wise men. I mean, they've taken myrrh. They really want it. The FDA wants to go after myrrh.
Jeez.
What did myrrh do? So I mean, it's really just a sort of threat to all the other potential sort of NAD therapies out there in the making, and to healthcare costs. And so that's really, and I really think the FDA is really the biggest obstacle to longevity. That's what I think. So,
okay. Well,
yeah.
I want to get into Alzheimer's here in a second, because I know you've been looking at that quite a bit, and both you guys have some pretty big thoughts on a multimodal approach to Alzheimer's and what we can do about Alzheimer's. But before that, you had briefly mentioned an article that I sent to you, Tom, about NAD uptake, and this one I will link to in the show notes over at bengreenfieldfitness.com/plasma. But it does show that most mammalian cell types can transport NAD across what's called the plasma membrane, from the extracellular medium and into the cell. And it does actually show a pretty significant amount of NAD uptake, despite the people that sell the NR supplements, which I have nothing against those NR supplements. I think they work. But a lot of folks will tell you NAD can't get absorbed. And I just, over and over again, I see data like this, and like you've just alluded to, Tom, that shows that it does. So So that whole debate, I think we could probably put a nail in that coffin and say that NAD does actually get absorbed, and again, for those of you who want to look at the research, we'll put some over at bengreenfieldfitness.com/plasma. But I know you have been using NAD to fight Alzheimer's disease. I know you guys have been using something called the Bredesen protocol. So tell me about what you've been doing when it comes to Alzheimer's.
Well, I've heard about Bredesen protocol, and when I've talked to a lot of functional medicine doctors, they just light up when they talk about Dale Bredesen and what he's been up to with Alzheimer's. And there was a speaker at my conference who talked about how he was combining NAD with Bredesen protocol, and he was seeing very good anecdotal results. And by the way, Ben, we'll be selling those videos with a discount, and we'll put those in the show notes as well. So if you're listening to this podcast and you want to watch the videos, and then we'll also just bundle that with the next NAD conference that we're going to be putting on in February too, if you want to go to that as well. So, okay. But Alzheimer's is a $500 billion disease. It's the 6th leading cause of death. And it's part of that 5% of society that makes up 50% of the cost of healthcare. And so we think that, looking at everything that we can to reverse Alzheimer's the risks are outweighed by, the potential of looking at a lot of different therapies. And so, when you look at some of the things that Bredesen does, so Bredesen's protocol, I mean, he talks about using a metaphor where Alzheimer's disease is like a roof with 36 holes, in which, if it's raining, you're going to have 36 leaks, and each hole needs to be filled in order to achieve the best outcome and even reverse, he claims, reverse Alzheimer's disease. So the 36 hole roof represents 36 metabolic imbalances in the brain. And while previous Alzheimer's drugs are successful at filling 1 or 2 holes, his protocol addresses all 36 holes. So he sort of breaks down Alzheimer's into different sort of subtypes. So inflammatory markers, glycotoxic, which happens to do with sort of high carbohydrate, sort of diabetic, and then there's atrophic that has to do with hormone related, and then there's toxic, which has to do with things like mycotoxins and heavy metals, and then there's vascular, so cardiovascular, and then traumatic, which has to do with brain injury. It's what's people like to poo-poo, like say it's sort of like he seems to bring up a lot of the things that you bring up, like ketosis and using MCT oil, and it fits well with me. And doing intermittent fasting, so he has this sort of 12 hours off intermittent fasting and 3 hours. You don't eat 3 hours before going to bed. Doing low carb diet, this sort of thing. It's a lot of the stuff that you've talked about for a very long time, and so it's exciting to see sort of the cross pollination, of what you see in the sort of biohacking world and the sort of paleo world and what's happening here. And we've been looking at filing an IRB to do the NAD with his protocol. We actually even wanted to throw in the V-light. So I first stuck the V-light up my nose at your house.
A lot of people don't know what the V-light is. That's the photo biomodulation, it's basically like the laser light for your nose and for your head that they've done some interesting research behind. I have a whole podcast on it, but essentially it's like photo biomodulation, like infrared therapy that you put on your skull like a helmet. I have one sitting here beside me. It's right next to me right now because I wear it about every 48 hours, and it causes an activation of mitochondria and neural tissue, causes a release of nitric oxide. It's a pretty powerful little headset.
Yeah, and the manufacturer is doing a study with Alzheimer's right now out in Toronto. We just think it would be, when you're going after Alzheimer's, you want to just throw everything that you can. If it it seems like we seem to think that it's a rather safe therapy to combine. So there's a ton of precursors that have been sort of, there's been a lot of research that has been linked between NAD precursors and Alzheimer's, and Bredesen uses resveratrol and he uses nicotinamide riboside, and we'd like to, because anecdotally what you see in functional medicine practices, you see pronounced sort of cognitive changes with the IV NAD. We think that we hypothesize that potentially using a pure NAD is going to be promising to reversing this nasty disease. So we talked to Nady Brady about it. He wrote the book on NAD and neurodegeneration and aging, and he thought it was a great idea. So he's asked to be our primary investigator, and he was the first scientist to show that NAD levels decline with age. So it's a pretty good win to have him on board. But there's so much out there, and that's what gets us so excited. That's what gets Mark and I excited. I mean, maybe even the potential of using these exosomes that you've been talking about for Alzheimer's.
Are you guys using those as well, exosomes? And you would use them for Alzheimer's?
Yeah, there's a protocol that the Chimera has for Alzheimer's.
What's Chimera?
We haven't used it. Chimera is one of the labs that's producing sort of this undifferentiated broth of MSC, placenta-derived exosomes. So, gosh, that's a big term, but basically, I'm not the best at explaining what exosomes are. You're probably better, maybe, but they're extracellular vesicles that they're sort of messages in a bottle that communicate between cells.
Yeah, they're vesicles. Back when I was taking exercise physiology, they'd show us these photos of cells or these diagrams of cells that had these little tiny circles getting released from them, and people just thought that they were essentially almost like junk that the cell was releasing, but it turns out they're actual signaling molecules, and they have specialized functions like, not just intercellular signaling, but like waste management and blood coagulation. And they can also, when combined with stem cells, or even in the absence of stem cells, it appears actually allow for better trafficking of certain I guess like nutrient signals, etc., from cell to cell. They essentially are like the they're like the carriers, like the taxis from cell to cell. So they influence the immune system and the immune response to pathogens and tumors. And again, when I got injected with stem cells, they were almost used as a way to upgrade my stem cells. So yeah, pretty fascinating what they all can do, and they come from this Chimera lab that you just referred to.
Yeah, I mean they take stem cells, and then they treat them in such a way that they shed off these exosomes, these messages. They might be proteins, RNAs, microRNAs, and they're coming from this sort of rejuvenatory sort of placenta. And they've been using them for a number of different issues. I mean, you and I know we have a common friend who had a spinal cord injury, and we should probably put that in the show notes. I had him sign a release, but he's seen significant improvements in his spinal cord injury, where he's able to bend down more. and he's been able to have improvements in tone and spasticity from the spinal cord injury. And it's those kinds of moments that makes you want to go further and see how exciting the sort of cutting edge science can do. But like the cool thing is these exosomes have their homing capability, and they could some are anti-inflammatory, immunomodulating. And I was talking with the lead scientist there, and not only do their exosomes have the GDNF and BDNF, these are sort of neuronal RNAs, but it also has this sort of this GDF-11 microRNA, which is like sort of this, like, I don't know, GDF-11 is this sort of it's the RNA, so it produces the protein that has real potential. That's the interesting thing about talking to these people from RAD Fest is you talk to some of these folks. That there's this one lady that I spoke to, and she's claiming that her biological aging clocks have gone from her 70s to her 30s. And so, Steve Perry, who's going to be speaking at RAD Fest, he's going to be speaking about these 100 individuals that have took it upon themselves to inject themselves with GDF-11. But these exosomes have the RNA for GDF-11, so it's like these sort of the copy machine for GDF-11. So it's exciting.
You could get this GDF-11, which is like a DNA repair molecule that would act on stem cells to make them active again, and has like I know a little bit about GDF-11. It's got some pretty potent cardiac and muscular and neural effects. But what you're saying is that exosomes would allow you to get the same effects as GDF-11 or enhance your GDF-11 availability?
Potentially. I mean, no one really knows. I mean, this a lot of this stuff is so new. But no one really, like, at least I don't know what potentially can come out. But you hear sort of these stories, at least with the people that have, I've heard more stories from the people that have taken the GDF-11. They've seen improvements in it's an injection. It's like a very, very, very small dose, and they've seen improvements in sex drive, and they've seen improvements in hearing and smell and sight and things like that.
Do you guys do that injection down there at the NAD clinic?
No, but we'd like to. I mean, I think there might be some legal hurdles to go through in order to make that happen. So we'd be looking into that. You'd have to find a way to procure it. But it's just a really exciting part of longevity right now is this GDF-11. It's a hot topic.
The bottom line, while all this biohacking is kind of fun and cool and interesting, is how do you actually measure results? And a lot of people have got stories, but where the real fundamental question is, where's the data? What data supports what result? And that's kind of what we've been focused on is, okay, we've kind of built a platform to test anything. So I would say, Tom or Ben, I mean, anything you guys come across that you think, is merit worthy, we're in. I mean, we'll test it because, we're looking for a common yardstick to sort through, the myths, the stories, the hearsay, and all that to get to, hard data that says, hey, we saw these changes in the cellular cytokine panel, or we saw the stem cell progenitor panel changed or whatever, I mean, and look, all the how people feel, what their kind of anecdotal sense of things is, it's interesting. But the most fundamental question is, are you detecting a potential problem and preventing it? Are you rejuvenating something that you can measure a change? Can you measure myogenesis, growth in muscle cells, neurogenesis, growth in brain cells as a result of some treatment therapy? And so that's kind of the most fundamental issue, I think, in the anti-aging world right now. It's a crazy cacophony of characters, and if we're all going to benefit from this, at the end of the day, we need a common yardstick, or common yardsticks. And Tom's got a lot of cool stuff he's added to the mix, and we're kind of test junkies. I mean, we'll take anything that seems merit worthy. But we'll be equally critical of tests that aren't merit worthy. And right now, telomeres, that's kind of low on the list of having any merit. It kind of feels good, but it could change day to day based on the random blood draw. So we're trying to get to a place where we can get more definitive certainty around cause and effect associated with all this stuff, so we can all save time. It's just as valuable to figure out what's not working.
One of the other things I wanted to ask you guys about too was this idea of Senolytics, because I think it was Tom I heard talking about Senolytics, or this idea of senescent cells. Can you guys get into Senolytics a little bit and how that works?
Can I just say one more thing about Alzheimer's, and then before we transition over there?
Yeah.
I just want to say that there's a study that's been going on, or that concluded last year, over the last 4 years, using therapeutic plasma exchange to treat Alzheimer's patients. It hasn't been published yet. There's been some interim results published in 2016, and they're on our website. There's a link to them in the references section. But bottom line is, we hired a lot of nurses that were on that study, and they saw real recovery firsthand. And these are not like newbie nurses just out of nursing school. These are like nurse practitioners with 30, 40 years of experience who can tell you actual stories of actual people who actually recovered as a result of treatment therapies, and their families. So we're probably going to have a whole separate branch or arm that we're going to create that's going to be more Alzheimer's or neurologic specific. Right now, we've got kind of the big net for anything and everything anti-aging, including the minimally invasive Alzheimer's blood test. But we're probably going to, toward the end of this year or beginning of next year, create a protocol that more or less mimics the protocol that was used by Grifols over the last 4 years, over hundreds of patients and thousands of treatments. That, as I said, hasn't yet been published, but we have it on pretty good word that it worked. And we're pretty confident and I've met with some of the principal investigators as well. So we're pretty confident that, when they do publish, they'll show, positive results, as a result of the treatment therapy. And the cool thing is, it's like, hey, I think we're going to find out, the Bredesen stuff is great. There's a lot of other folks working on diet and neurological disorders and so forth, which we'd like to test, by the way, put it under a real formal clinical trial. But it may be a combination of these things. And it's like I tell people, look, we can change your oil, but if you keep putting garbage in the tank, you're going to screw up the engine again. So there may not be one right answer here, but the key is getting the data around this, and we're going to have the most advanced, most definitive, minimally invasive blood tests in the world for Alzheimer's that will objectify some of the answers here.
Wow, that's fascinating that you guys have gotten those kind of results with Alzheimer's. I've never heard of it being reversed to that extent. So that's going to be very interesting for a lot of people.
Well, these are right now, you have to put it in the category of, nurses' lore, because it hasn't been, published, but it was a very rigorous clinical study. And we do expect they will publish their results, within the next, 6 to 12 months. And, we just sort of got to jump on it because we hired a few nurses that happen to, be on duty administering the treatment.
Wow. So what about this Senolytics thing?
So, unlike plasmapheresis that has so many years and it's been used so many times, and Senolytics is sort of a newer technology. It's Senolytics is a broad term to describe small molecules which selectively induce death of the majority of senescent cells. So a senescent cell, they're basically like zombie cells that live in your body, and as you age, you accumulate more of these zombie cells that don't really help out the rest of your body, and they excrete they give off chronic inflammation, increased risk of cancer, and secrete pro-inflammatory cytokines, chemokines, and extracellular matrix proteases, which contribute to aging and cancer. So there's companies like Uni Biotechnology that are out there, but I've spoken to some people, some of the folks that'll be at RAD Fest about how they've been experimenting with some of these therapies, and some of them I don't even really want to talk about because they're so new and there's sort of risk apparent to them. But the idea is to get rid of some, but not all of these zombie cells, because apparently you need to have some of these cells to keep to keep healthy. You don't want to eliminate all of them. But I mean, right now, what you're going to see, Life Extension, I think, did an article, and I'll post that in the notes, where they're recommending taking 150 milligrams of tocotrienols. It's like a vitamin E spectrum per day, and then 500 to 800 milligrams of quercetin per day as a way of minimizing the damage from senescent cells. So it's really exciting because it's this anti-aging therapy that I've heard people talk. I've heard people talking about how they've got more energy, and there'll be more of an in-depth sort of more knowledgeable explanation at RAD Fest.
So quercetin would be a supplement that you would take to actually stave off the development of these senescent cells?
Yeah, quercetin, it's found in onions, and then
you get that in apples too.
Apples, yeah, that's right.
But you would take this in like supplement form to get a lot more than you get from, say, onions and apples.
Yeah, I think so.
Interesting. Wow, I mean, a lot of this stuff people are just unaware of, like GDF-11 injections or even NAD IVs, along with the reverse of Alzheimer's from things like plasma exchange therapy, or you see these quercetin and tocotrienols to decrease senescent cell formation. I mean, there's a lot here, and I realize that we've only really scratched the surface. I know you've sent me a ton of studies I need to dig through and add to the show notes, Tom, and I'm going to be doing all that and creating some pretty robust show notes for you guys who want to take a deep dive over at bengreenfieldfitness.com/plasma. I know we got kind of sciencey during today's show, and my apologies. Hopefully everybody was able to kind of keep up with some of the stuff we were chatting about. But I would recommend that for any of you who are interested in kind of keeping your finger on the pulse of all this, that you check out the links I'll have in the show notes, and you follow what Tom is doing and you follow what Mark is doing, because I do talk to these guys and they really are on the cutting edge of a lot of this stuff. And I would recommend that you follow them, follow their clinics. And again, I'll link to everything. I'll also link, for those of you who want the last minute to get into this RAD Fest, I'll link to RAD Fest in the show notes. And perhaps for those of you who like to plan things out and plan out your conferences in advance, I'll also link to this NAD conference that's going to take place in February. For those of you who want to get down to that, I'll probably go to that one myself. I don't think I'm going to make it to this RAD Fest, but I'll probably be at that NAD conference. And Tom, Mark, anything else you guys want to bring up before I let you go?
Great job, Ben.
Thanks, Ben.
Awesome. Well, thanks for coming on, guys. And again, folks, if you want to take a deep dive into any of this stuff, just go to bengreenfieldfitness.com/plasma. That's bengreenfieldfitness.com/plasma. I'll put links to all these conferences, all these studies, pretty much everything that we talked about in the show notes over there. Until next time, I'm Ben Greenfield, along with Tom Ingloglia and Mark Erdahl, signing out from bengreenfieldfitness.com. Have an amazing week.
You've been listening to the Ben Greenfield Fitness Podcast. Go to bengreenfieldfitness.com for even more cutting-edge fitness and performance advice.